Hey there students, it's Miss Adams, and in this video, we're going to talk a little bit more about correlation.
All right, the correlation formula is, if you wanted to calculate it out by hand, is the summation of each individual x value minus the mean of the x values divided by the standard deviation of the x values. So that would be the z-score of your x values times the z-score of your y values divided by n minus 1. All right, and remember we use n minus 1 as like a degrees of freedom, kind of a buffer. All right, you're not going to be expected to really use that formula. Your calculator does all of the calculations for you, but it is good to know that it's coming from the z-scores. All right, and you have to have two quantitative variables because it's using x z-scores and y z-scores. All right, how to find R in your calculator. So you're going to press Stat, Edit, and you're going to add your data into list 1 and list 2. So your x data is going to go in list 1, your y data is going to go in list 2. Then you're going to go to Stat, Calc, and you're going to pick option 8, linear regression A plus BX, and make sure you're using the right list so that you're using list 1 and list 2, and you're looking for R, which is the correlation coefficient. If this is the first time you're doing this, or if your calculator has been reset, you'll have to turn Stat Diagnostics on, which I'll show you how to do. Outliers and correlation. All right. Outliers greatly influence the correlation because the formula uses the mean and standard deviation, which are not resistant to outliers. Okay. And properties of the correlation. Correlation makes no distinction between the explanatory and response variable, your x and your y variable. Because R uses the standardized values of the observations, R does not change when we change the units of measurement. Okay, so remember z-scores have no units, so correlation also has no units. All right, calculating the correlation. The table shows the number of touchdowns and the number of wins for 4 teams in the NFC West division of the NFL during a recent season. Calculate the correlation. So we're going to put this data into list 1 and this data into list 2. We're going to go Stat Calc 8, and we should get R equals 0.9908. Let me show you what this looks like in the calculator. All right, so in the calculator, we're going to go, first we need to turn Stat Diagnostic on. Once you turn this on, if you don't reset your calculator, it will still be there. So you're going to scroll down until you see Stat Diagnostic, and you're going to switch it to on and click Enter. All right, once that's on, it'll stay on unless you reset your calculator. Then we're going to go to Stat, Edit, and we're going to put our X values into list 1, number of touchdowns, our Y values into list 2, number of wins. Once we have the data in our list, we're going to go to Stat, we're going to go over to Calc, we're going to pick option 8, linear regression A plus BX. My X list is list 1, my Y list is list 2. I don't need to worry about the rest of this stuff, and I'm going to go down to Calculate. And R, my correlation coefficient, is 0.99078, which I rounded to 0.9908. All right, let's explore some of the properties of correlation. The scatter plot shows the relationship between the amount of weight students can squat and bench press. The correlation is R equals 0.939. So you can see the scatter plot there. You can see there's a positive relationship. So as they're able to bench press more weight, they're also able to squat more weight. What would happen to the correlation if squat weight was plotted on the horizontal axis and bench press weight was plotted on the vertical axis? So if I flip-flop what's on the X and the Y, what would happen? So the correlation would stay the same, 0.939. Remember, that's the relationship between those two things. So it's just as strong of a relationship. Correlation makes no distinction between the explanatory and the response variable. All right, it's just measuring the relationship between those two variables. What would happen to the correlation if squat weight was measured in kilograms instead of pounds? So the correlation, again, would stay the same, 0.939. Correlation doesn't change when we change the units. All right, correlation is not tied to the units at all. It's just the measure of the strength of the relationship between the two variables. All right, Eli claims that the correlation between squat weight and bench press weight is 0.939 pounds. Is this correct? So, no, correlation doesn't have units. so it should not include the word pounds. All right, outliers. How do the 2 points circled in the upper right corner of the graph affect the correlation? Well, if we didn't have those points, without those 2 points, the correlation would definitely be negative. But because it's further on the x-axis, it has a lot more pull. It's able to have more leverage on the line of best fit. And so it's pulling the correlation closer to 0 and even possibly positive.
All right, that's all for now. Thanks, and see you next time.